April 12th, 1950, Palomar Mountain, California. A telescope built to photograph the entire northern sky is doing exactly that, quietly, patiently, exposure after exposure, on glass plates coated in silver emulsion. At 8:52 in the evening, the plate captures the sky. Half an hour later, a second plate captures the same patch of sky again. In between those two exposures, 9 points of light appear in a nearly straight line, bright, sharp, unmistakable. And then, on every photograph taken afterward, forever, they are gone. No comet did this, no satellite did this. Here's the problem. In 1950, there were no satellites. Sputnik, humanity's first, wouldn't reach orbit for another 7 years. So what did 76 years of scientists just find sitting quietly in a photo archive, waiting to be noticed? Today is July 21st, 2026, and this question has just split the astronomical community in two. On one side, a small group of physicists who say they found a signature consistent with solar glints off metallic objects in orbit around Earth, before Earth is supposed to have had anything in orbit at all. On the other, a growing chorus of scientists who say the whole thing is an illusion built out of scratched film and bad statistics. Neither side has blinked. And in the last 4 months, the argument has gotten sharper, stranger, and a great deal more public. This is not a UFO video. There are no blurry green men, no leaked government files, no grainy night vision footage. This is something rarer, and in some ways more unsettling. A real scientific paper trail, published in real peer-reviewed journals, arguing over real photographic evidence that something reflective may have been orbiting our planet before humans ever put anything up there. Let's go through exactly what was found, what has been confirmed, what is still just a theory, and why, this year, some serious scientists are calling it the strongest data point we have. To understand why a set of 70-year-old photographs is making headlines in 2026, you have to understand what they were never meant to find. Between 1949 and 1958, the Palomar Observatory in California ran one of the most ambitious sky mapping projects of the 20th century. The first Palomar Observatory Sky Survey, known to astronomers simply as POSSI. Using a 48-inch telescope, the survey systematically photographed almost the entire visible northern sky onto thousands of glass photographic plates. It became one of the foundational reference maps of modern astronomy. The sky, frozen in silver halide, before the space age had even begun. That last detail matters more than anything else in this story. POSSI plates were exposed. Years before Sputnik 1 launched on October 4th, 1957. There were no artificial satellites yet, no space debris, no orbiting hardware of any kind, human or otherwise, at least not according to the history books. For decades, these plates simply sat in archives, used the way old maps are used, as a baseline, a before picture to compare against the modern sky. Then, starting around 2020, a Swedish astrophysicist named Beatrice Villaroel, working at the Nordic Institute for Theoretical Physics in Stockholm, began a project with a deliberately strange goal. It was called VASCO, Vanishing and Appearing Sources During a Century of Observations. The idea was almost embarrassingly simple. Take those old plates, compare them star by star against modern digital sky surveys, and look for objects that are present in one and completely absent in the other. Stars that seem to have vanished. Villaroel's team wasn't hunting for anything exotic. They were hunting for genuine astrophysical oddities. A star that dims into invisibility, perhaps, or a rare and rapid stellar collapse. Having examined roughly 600 million catalogued sources, they found no confirmed case of a star that simply blinked out of existence. Zero. That part of the search came back empty. But while sifting through the plates, they noticed something they weren't looking for at all. On that April night in 1950, a single plate showed 9 bright, point-like sources arranged in a rough line, clustered closely together. They were not present on a plate taken 30 minutes earlier. They were never seen again, not on any later observation, not in any modern survey, not even using the Gran Telescopio Canarias, one of the largest optical telescopes on Earth, pointed directly at that patch of sky in follow-up searches. Nothing. No trace, no counterpart, down to extraordinarily faint magnitudes. Villaroel described the moment plainly. 9 stars appeared, and 30 minutes earlier they weren't there, and 6 days later they weren't there either. You look at that, she said, and you have to ask yourself, is this even real? It turned out this April 1950 image wasn't an isolated fluke. As the VASCO team dug deeper into the archive, they found thousands more of these brief, unexplained flashes. Objects present in a single frame and absent from every subsequent one. As of the most recent published catalog, the VASCO project lists over 107,000 candidate transients across the POSSI plates. A separate related search specifically for vanishing point sources identified more than 5,000 additional candidates using automated matching against the virtual observatory. Now, A crucial verified fact, one that isn't up for scientific debate. The overwhelming majority of these transients are almost certainly mundane. Old photographic plates are physically messy things. Dust settles on emulsion, chemicals streak, scanners introduce artifacts, cosmic rays strike film during processing and leave a bright dot that looks exactly like a star that was never there. Anyone claiming that 100,000 pinpricks of light are all evidence of alien hardware would be, quite simply, wrong, and no scientist involved in this research has made that claim. What makes the story interesting isn't the pile of noise. It's a small, specific subset of these events that resisted every mundane explanation the team could throw at them, events that behaved less like flaws in a photograph and more like flashes of actual light that were really there, reflecting off something in the actual sky before humans had built anything to put in it. That distinction between unexplained plate artifact and possible physical object is the entire fight that has consumed the astronomical literature for the past 2 years, and especially the past few months. And it's the fight we're about to walk through, piece by piece, starting with the evidence that convinced a growing number of physicists this deserved a second, much harder look. Because a photograph of light that shouldn't be there is a curiosity. A photograph of light that shouldn't be there, behaving exactly the way an orbiting reflector would behave, repeated again and again across an entire decade of data, is something else entirely. If you wanted to prove that a flash of light in a 70-year-old photograph came from something orbiting the Earth, rather than a scratch, a dust speck, or a random cosmic ray, you'd need more than one piece of evidence. You'd need several independent tests that all point the same direction. Over the past 2 years, that's precisely what a widening circle of researchers has tried to build. 4 separate lines of evidence now converge on the same idea, and each one on its own would be interesting. Together, they're why this story refuses to die. Test 1. The shadow of the Earth. Here is the logic, and it's elegant. If these flashes are sunlight glinting off a physical reflective object in orbit, then there is one place in the sky where that glint simply cannot happen. Inside the Earth's own shadow. An object orbiting within that shadow cone receives no direct sunlight, so it cannot reflect any. If the transients are real orbital glints, astronomers should see a measurable drop-off in transient detections whenever the geometry places the observed patch of sky inside Earth's umbra. That is exactly what Villarreal's team reported. Confirmed finding. Their analysis found a statistically significant deficit of transients within the Earth's shadow region, a pattern the team argues is difficult to explain through plate contamination, since a scratch or a dust speck has no idea where the Earth's shadow is and would show no such preference. The geometry of the deficit also pointed to something specific, a population of objects clustered near geosynchronous altitude, roughly 36,000 kilometers up, far higher than where a stray weather balloon or aircraft could ever be. Test 2. The shape of the light itself. This is where the story picked up serious momentum in 2026. A former NASA software developer, Ivo Busco, went back to a related archive, plates from the Hamburg Observatory in Germany, digitized through a project called Applaus, and studied the optical profile of the light in these transient events with extreme care. Confirmed finding, published in his March 2026 paper. For a specific set of these flashes, the pattern of light showed a distortion called coma, a very particular kind of optical smear that only happens when light enters a telescope's mirror off-axis, at an angle. It's a fingerprint of the optics themselves, not of the film. Why does that matter so much? Because a defect on the plate, a stain, a hair, a chemical blemish, happens after the light has already been focused. It has no relationship whatsoever to the telescope's optical geometry. But genuine starlight, or genuine reflected light passing through the telescope, does carry that signature. Busco's analysis effectively argued, for at least a subset of these events, we can now show the light physically passed through the telescope's optics. It was really in the sky. It was not conjured by a dirty plate. Test 3, the nuclear connection. This is the finding that turns an astronomical curiosity into something genuinely eerie. In 2025, researchers Sarah Bruhl and Beatriz Villarreal published an analysis comparing the dates of these transient detections against the dates of atmospheric nuclear weapons tests conducted by the United States and the Soviet Union during that same 1949 to 1957 window. Confirmed statistical finding, published in scientific reports. They reported an elevated rate of transient detections within roughly a day of nuclear test dates, a correlation strong enough to register at a confidence level scientists described as statistically significant. And notably, a similar correlation showed up with reports of unidentified anomalous phenomena from that same era. That result did not stay unchallenged for long, and this is where independent verification became critical. A researcher named Doherty ran a separate statistical replication in 2026, this time controlling, for factors that could easily fool a simpler analysis: cloud cover, moonlight, rainfall. The correlation held. Another independent coder, working under the name Synconin, built a fresh detection pipeline from scratch and reported a similar pattern. Then, in April 2026, an independent researcher named Kevin Can added a further physical variable nobody had tested before: geomagnetic storm activity measured by a standard space weather index called CAPO. Confirmed finding: transient detection rates dropped in a clean, stepwise pattern as geomagnetic activity increased, from roughly 17% during quiet space weather periods down to about 2% during the most intense storms. That's exactly the pattern you'd expect if the light source sits near geosynchronous orbit, a region of space known to be disturbed by geomagnetic storms in ways that could plausibly suppress a reflective object's visibility. Test 4, they keep finding it independently. The single most important thing to understand about this entire case is that no one group's word is being taken on faith. Multiple, separate teams, using different code, different plate subsets, different statistical methods, have each gone looking for these patterns from scratch without simply copying the original analysis, and each time broadly similar signals have turned up again. Now, here's the necessary, honest caveat, and it's an important one to sit with. Correlation is not causation, and consistent with is not the same as proven. No researcher in this field, not Villarroel, not Busco, not any of their collaborators, has published a claim that says in plain language, "We have found alien spacecraft." What they have published, carefully and repeatedly, is narrower: that a specific, statistically distinct subset of these 1950s transients behaves like sunlight, reflecting off small, flat, highly reflective, artificial-looking objects in high Earth orbit, years before humanity is known to have put anything there. That is the theory. It is not confirmed fact. But by the middle of 2026, it had survived 4 independent quantitative tests in a row, which is exactly why the rest of the astronomical community decided it was time to hit it as hard as they could. Extraordinary claims, as the old scientific saying goes, demand extraordinary evidence. And nothing tests a claim like this faster than putting it directly in front of scientists whose entire job is to find the flaw. In February 2026, a team led by astronomer Wesley Waters, joined by researchers including Kevin Knuth, one of the very physicists who had previously co-authored papers alongside Villarroel on unidentified phenomena, published a direct, pointed rebuttal titled "Critical Evaluation of Studies," alleging evidence for technosignatures in the POSS-1E photographic plates. This wasn't an outside attack from strangers. This was, in effect, former collaborators turning a critical eye on the data itself. Their argument runs on several fronts, and it deserves to be laid out fairly. First, history. Waters and his colleagues point out accurately that archival photographic plates have fooled astronomers before. Decades of searches for optical flashes tied to gamma-ray bursts, conducted using old sky survey plates, repeatedly turned up candidate transients that later proved to be nothing more than common emulsion defects, scratches, chemical spots, processing artifacts that mimic a star-like point of light with unsettling precision. Photographic plates, in short, have a long and well-documented history of lying to us in exactly this way. Second, and more technically, sample purity. The Waters team argued that when you take the raw catalog of over 100,000 transient candidates and start filtering it down to the cleanest possible subset, the events least likely to be plate defects, the resulting sample shrinks by a factor of roughly 20. Their concern is straightforward. If you have to throw away 95% of your data to find the signal, how confident can you really be that the remaining 5% represents something physically real rather than a statistical accident dressed up by aggressive filtering? Third, methodology. The critique raised specific technical objections about how positions on the plates were measured and converted into inferred observation times, details in the geometry of the analysis that, if handled incorrectly, could distort results like the reported Earth shadow deficit. They also noted that some of the original analyses lacked full uncertainty. Estimates. The error bars that let other scientists judge how much to trust a given number. Villarroel's team did not stay quiet. In a formal response, published later in 2026, they pushed back point by point. Their central argument: the Waters critique, they said, mixes up 2 very different kinds of scientific claims, confirming that any single individual transient is definitely real, versus showing a statistical pattern across a large population of transients taken together. You don't need to prove every single dot is a spaceship, they argued, to show that the population as a whole behaves strangely. They also disputed whether the smaller, heavily filtered subset Waters used was actually any cleaner than the full dataset, noting that their own visual inspection didn't support that claim, and that the reduced sample was, in their view, too small and too incomplete to fairly test something as specific as the Earth shadow deficit in the first place. On the geometric measurement question, they maintained that the correct mathematical adjustments had, in fact, been applied. So where does that leave us, honestly, as of today? Unresolved. Genuinely, actively unresolved. And that's worth saying plainly because it's the most scientifically honest thing anyone can say about this story right now. This is not a case of one side being quietly debunked while claiming victory anyway. It's an open technical argument playing out in real time in public preprints between scientists who were, until recently, co-authors on the same papers. Sabine Hossenfelder, a physicist well known for her sharp skepticism of exotic claims, covered the original findings and treated them as a genuine, physically interesting anomaly worth taking seriously. Not proof, but not nothing either. Other independent commentators in the space and science press have landed in similarly cautious territory. Real anomaly, unconfirmed. Cause. And that, in the end, might be the most important lesson buried inside this entire controversy. This isn't a story about a UFO sighting that a scientist casually waved away, or a conspiracy theory dressed up in academic language. This is what an actual functioning scientific mystery looks like while it's still being solved. Messy, contested, argued over in public, built on replication and counter-replication rather than a single dramatic reveal. Which brings us to the question underneath all of it. If even a fraction of this holds up, what would it actually mean? Let's take the theory at its strongest, most literal reading for a moment. Not because it's proven, but because it's worth understanding exactly what is being proposed and exactly what is not. If the small subset of surviving unexplained transients really are sunlight glinting off flat, rotating artificial objects near geosynchronous orbit, and if they really were there in 1949, 1950, 1952 years before any human satellite existed, then something was orbiting Earth before we had the technology to put anything there ourselves. That single sentence is doing a lot of heavy lifting, so let's be precise about what it would and would not prove. It would not automatically mean aliens in the cinematic sense. Visitors, contact, intent. Scientists working in this field use a more careful term for this entire category of search, technosignatures. Evidence not of biology, but of technology, something built by something that isn't us, a radio signal, an unusual chemical signature in a planet's atmosphere. Or in this case, a physical object that reflects sunlight the way engineered hardware does, sitting in a place and at a time where engineered hardware, as far as our history books know, did not yet exist. Could it instead be some undiscovered secret human program from the early Cold War, classified satellites, decades ahead of the official historical record? Researchers examining this question have pointed out that this explanation carries its own steep problems. It would require not just secret launch capability years before Sputnik, but reason those hidden objects would specifically glint in patterns correlated with nuclear detonations halfway around the world, a coincidence that would itself demand its own explanation. Could it be an unknown natural or atmospheric phenomenon nobody has cataloged yet? Possible. And honestly, still one of the more likely mundane candidates on the table, the one that, so far, hasn't been pinned down either. And could the entire signal, despite 4 rounds of independent statistical testing, still collapse under more rigorous scrutiny, revealing itself as an artifact of old chemistry, old glass, and modern pattern seeking? Also possible. Science has been humbled by less. It's worth placing this story next to the other strongest evidence headlines making. The rounds in 2025 and 2026, because the contrast is instructive. Astronomers studying the exoplanet K2-18b reported a possible detection of dimethyl sulfide, a molecule strongly associated with biological activity here on Earth. In that planet's atmosphere, a result press release is called the strongest hints yet of life beyond our solar system. NASA's Perseverance rover, examining a Martian rock nicknamed Chayava Falls, found chemical and textural features that an agency official described as the closest humanity has ever come to detecting a possible biosignature on Mars. Neither of those cases is confirmed either. When astrobiologists themselves were surveyed on how convinced they were by these announcements, expert opinion came back genuinely divided, some cautiously optimistic, many far more reserved, almost none willing to call either case settled. That's the honest state of the entire search for alien life in 2026. Multiple genuinely interesting anomalies, investigated by serious scientists using real data and real statistics, none of them crossing the finish line into confirmed fact. No credible government investigation, not the U.S. Air Force's historic Project Blue Book, not NASA's own independent 2023 review of unidentified aerial phenomena, has ever produced confirmed evidence of extraterrestrial technology or contact. That remains true today. So why does this particular story, a set of vanishing lights and 76-year-old photographs, keep getting called our strongest? Evidence? Perhaps because of what it doesn't require you to believe. You don't need a blurry photograph taken by a stranger with a shaking hand. You don't need to trust an anonymous government whistleblower. You need only trust a public, physical, endlessly re-examinable archive. The same glass plates anyone can request. The same digitized scans anyone can download. The same statistics anyone can rerun. 4 separate research groups have now taken their own independent runs at that archive, using different tools, different assumptions, different code. And 4 separate times, some version of the same strange signal has refused to fully disappear. That doesn't make it true. It makes it durable. And in a field littered with claims that evaporate the moment someone checks the math, durability is its own kind of remarkable. Somewhere in an archive drawer, on a sheet of glass exposed on an ordinary April evening in 1950, 9 points of light appeared, sat still for a fraction of a second, and then vanished from the universe as completely as if they had never existed at all. 76 years later, we still don't know what they were. Maybe it's dust on old film. Maybe it's a secret we've simply forgotten. Or maybe, and this is the possibility that no serious scientist has yet managed to fully rule out, maybe something was already watching this planet, quietly reflecting our own sunlight back at us, years before we ever thought to look up and build something of our own. Consider, for a moment, what makes this different from almost every other evidence of aliens story you have ever heard. There is no single witness to disbelieve or believe. There is no photograph that only one person has ever held. Every plate, every scan, every line of code used to hunt through them is sitting in a public archive or a public preprint, waiting for the next skeptic, the next physicist, the next 20-year-old graduate student, with a laptop and a grudge against sloppy statistics, to come along and try to break it. Science doesn't usually get to settle its biggest questions by vote or by vibe. It settles them by attrition, by throwing every reasonable objection at a claim over years, until either the claim shatters or it doesn't. So far, this one hasn't shattered. It has bent, been challenged, been defended, and bent again. That is not the same as being proven. But it is the only honest way anything in this line of research is ever going to get taken seriously. And it's worth remembering the next time a headline promises definitive proof of anything in space. Definitive proof rarely arrives all at once. It arrives, if it arrives at all, exactly like this. Slowly, argumentatively, one stubborn data point at a time. The plates are still there. The data is still open. And as of today, July 21st, 2026, the argument isn't over. It's just getting started.